My name is Connor Cullian, and I'm an applications expert here with MLCCAD Systems. Just a little bit about myself. I'm actually originally from the Chicago suburbs. However, I've relocated and I work out of our Austin, Texas headquarters here for MLCCAD Systems. I graduated from the University of Iowa in 2017 with a degree in engineering. Upon graduating, I worked for a couple years as a product design engineer, designing and optimizing mechanical and pneumatic suspension seating systems for the work truck off-road vehicle industry before coming on board to MLCCAD Systems. In my free time, I enjoy staying active, being outdoors, and most importantly, spending time with my family and my friends here. So that's enough about me. Let's go ahead and let me introduce you to the star of the show today, and that is MLCCAD Systems. So MLCCAD Systems is a value-added reseller for Markforged, Mastercam, and SolidWorks. And essentially, these companies distribute their products through a dealership network, if you will, where they do not sell or support their products, which allows them to focus on producing great software and great products. And that's where we, the value-added reseller, come into play. This allows us to provide unbeatable service, customer support, and training solutions that enables our customers, so you guys, to create better quality products for cheaper costs and at faster time to market speeds. So at MLCCAD Systems, we take the unbeatable service very seriously. Hopefully you've had the experience to work with us and experience that firsthand. And if not, hopefully we'll get to work together in the future. So as everyone is aware, SolidWorks is a 3D mechanical design software that comes in 3 different packages. First, we've got our standard package, then our professional package, and then lastly, our premium package. What we're going to be exploring today is actually outside the realm of all these packages, and it's its own brand called SolidWorks MBD. But before we go ahead and take a look at SolidWorks MBD, I just want to run through a quick history lesson to show you guys how we got to where we are today. So taking us back many, many moons ago, some of you guys may know this, some of you may not, but designs were actually hand-drawn on drafting boards. Then, with great technological advancements and the introduction of personalized computing, came 2D computer-aided design capabilities. And this was a huge leap forward in advancements. Then eventually bringing us to where we are today with very powerful 3D CAD capabilities and 2D drawings. So why are we inputting all of our data into these rich 3D CAD models and then stepping backwards to represent and condense all that information into 2D drawings for manufacturing? With very intricate designs and views, this information can certainly be difficult to understand and extremely easy to misinterpret, leaving a lot of ambiguity up in the air as to how a part or an assembly is to be manufactured. Additionally, updating drawings every time you make a change or a revision can be very time-consuming. So why are we still manufacturing our parts from 2D drawings? Well, that's where SOLIDWORKS MBD comes into play. MBD stands for Model-Based Definition, and it allows you to define, organize, and publish your product manufacturing information, also known as PMI, all within your 3D model and in accordance to industry standards. With SOLIDWORKS MBD, you no longer have to worry about any fake dimensions or maybe your models not matching your drawings because all the PMI is driven and represented right there in those 3D models like you can see here on my screen. Now, one major misconception that I actually hear a lot about when discussing MBD is the argument drawingless versus paperless. Let's just start here. These are not the same thing. Drawings are a presentation style, whereas paper is a type of communication form. MBD is a drawingless manufacturing solution, as it allows you to publish your 3D PMI in a couple different formats, one being 3D PDFs and the other being e-drawings. 3D PDFs can be printed as paper copies. So by implementing MBD, it doesn't mean that you have to go paperless. I know there's certainly several situations that I can think of where paper copies can certainly be more useful than digital devices. But by going drawingless, it's one less document per part and assembly that you have to maintain and update, since all the PMI automatically updates within your 3D model with SOLIDWORKS MBD. So due to time constraints, we aren't going to actually be able to touch upon everything inside SOLIDWORKS MBD, but to give you guys just an outline of what we're going to be covering today, first, we're going to take a look at creating 3D annotations and seeing how we can organize those. This is where most of the legwork is going to be and most of the important parts here. Then we'll take a look at capturing and setting up our 3D views for those 3D annotations. And then finally, we'll examine publishing this 3D PMI into 3D PDFs and e-drawing file formats for those that are not working with SOLIDWORKS. So that's what's on the agenda. Let's go ahead and get started. So switching over to SOLIDWORKS here, we can see that we're just going to be working with a simple mounting bracket today to examine SOLIDWORKS MBD. And just like anything else within SOLIDWORKS, there's going to be multiple ways to achieve either similar or the same results. So we're going to focus in on this first option for creating and generating this PMI onto our 3D model by just leveraging the data that we've already actually inputted by creating this model and its features. So note, this is where the most legwork does come into play, is actually going ahead and creating and annotating our model here. So SOLIDWORKS actually stores all that information related to your design right here in the Annotations folder. Inside here, you'll notice that SOLIDWORKS has automatically gone ahead and created some views based on how this part was constructed. So taking a look here, we'll see we also have an unassigned items folder. The unassigned items folder is actually where a lot of information is stored that is not related to any of the specified views, either being a front, back, left, right, top, or bottom view. So taking a look, we can actually go ahead and analyze what dimensions in PMI was stored under this unassigned items view here. When we go ahead and we click on these, you'll actually notice that most of these, if not all of them, are related to that edge flange there and that face, and we can't actually orient our model according to that view since this stores all the unassigned items. This could be related to any other faces as well. So let's go ahead and let's first start off by creating a new view to store those annotations there. So as you can see, we've got some selections here related to our standard viewports, but if we want, we can easily just go in and add a new one that's perpendicular to that edge flange there. And we can just go ahead and start moving these dimensions on over. We can go ahead and select them all from in the graphics area. And go ahead and move them to our new view. So now that they're all moved over to our new view here, we can go ahead and rename our view. Since SOLIDWORKS just gives it a basic name there, we can go ahead and just call it AUX, standing for Auxiliary View. And from here, we could just go ahead and take a look at reorganizing that. Since we are leveraging the data that we've already inputted in here, it might just take some cleanup work, just like cleaning up a 2D drawing. So we could go ahead and drag these out accordingly. And I know that this 12.5 millimeter radius should actually be calling out the top and the bottom fillet there. So if we need, we can always just go ahead and easily make a change to accommodate for that. And I think that looks pretty good for this view. So let's go ahead and let's take a look at some of the other views that SOLIDWORKS has automatically gone ahead and stored that information that we've created our model from. So again, maybe just some minor cleanup, but all this information that we've already inputted into our model here is stored within our 3D model, making it really easy to go ahead and create this PMI and show that right on top of our 3D model here. So we could continue to take a look at some of the other viewports here, just do some minor cleanup work. Maybe we'll notice that there are some additional dimensions that we could easily go ahead and add in. And that's just as easy as bringing in some smart dimensions, just like a 2D drawing here. Go ahead and select the edge And now we're controlling that whole location in regards to that front edge there. So now you may actually notice here, we do have some difference in colors for our dimensions, and that's just based on how that they were actually created. So those black dimensions there are sketch dimensions, the blue dimensions are feature dimensions, and that new dimension that we created there in gray is actually a reference dimension. So SOLIDWORKS is smart enough to store all that information right there in your model. So taking a look here, we could easily go ahead and take a look at all the information here that's been stored as PMI into our model by just showing all of our viewports here. And this is a great way to leverage all the data that we've already inputted into our design, so we don't have to go ahead and recreate those annotations. And we can see here how this part was created with way less ambiguity in regards to a 2D drawing. You know, we can go ahead and we can rotate our model, see exactly where a dimension is actually being pulled from, rather than a black and white 2D drawing, which may be very confusing. Now, this is a great way to leverage the data that we've already inputted into our model and get a feel for setting up our PMI. However, this doesn't actually take full advantage of the capabilities of SOLIDWORKS MBD. And in order to do that, we want to go ahead and we want to access the MBD tab from the command manager, where you'll see all these specific commands related to creating model-based definitions. Now, the second option we're going to be taking a look at for generating and displaying this PMI information onto our model is by making use of the DIM Expert tool. The DIM Expert tool is actually available with every seat of SOLIDWORKS. However, in regards to what is specifically related to SOLIDWORKS MBD, anything to the right of where my cursor is, so the import scheme, all the way to adding surface finishes, weld symbols, capturing 3D views, creating specific section views, model break views, and publishing your 3D PMI is all specific to SOLIDWORKS MBD. So in order to access this, you do have to have that license. However, if you are just looking to create PMI onto your model, any seat of SOLIDWORKS has that capability with the second option here that we're going to be using. So since we've already taken a look at manually creating a couple dimensions there, in our first option, we're actually going to focus in on the ability to create a auto dimension scheme here, which will essentially automatically dimension and tolerance our part based on the manufacturing topology found in the model. So SOLIDWORKS will go ahead and apply the appropriate annotations based on ASME or ISO standards. So applying a auto dimension scheme here, we can see that SOLIDWORKS gives us the option to define a primary, secondary, and tertiary datum. We don't have to define all of these if we don't want to, but for this instance, we're going to have it try and create dimensions and tolerances for all of our features if possible. So we can go ahead and we can select those. And then, like I mentioned, we're going to have SOLIDWORKS go ahead and create this for as many features as possible. But you do have the option to go ahead and select just selected features if you don't want it to select and create dimensions and tolerances for all the potential features there. When we go ahead and we click OK, notice how SOLIDWORKS immediately gives us instantaneous feedback as to whether our part is fully or under or over constrained here. So just by looking at the colors here on our model that's been overlaid, we can tell if we have the appropriate amount of PMI to go ahead and manufacture this component here safely. So any of the faces that are shown here in yellow are actually under constrained. The ones shown in green are fully constrained. And if we had any red faces, which it doesn't look like we do, those would be over-constrained. And if we did actually have an over-constrained face, SOLIDWORKS would go ahead and notify us, giving us a warning, letting us know that, hey, we've got an over-constrained face here, or a feature. So just by taking a look at our model here, we can easily tell that we do need to go ahead and manually input some additional dimensions here to go ahead and make sure that our part is fully constrained, making sure that we can manufacture this properly here. Also, one thing to point out, the difference between creating dimensions with the DIM Expert versus just leveraging your data that you've already inputted into your models by creating those features is the ability to cross dynamically highlight your model here. So when we go ahead and we click on a dimension, one of the PMI dimensions there, we can see that it automatically highlights the face of that feature that it is pointing out in regards to. So removing any ambiguity that you might have on a 2D drawing where you don't know where that dimension is actually being called out to, we selected the 57.96 dimension there. We can see that it's going to the center of this keyhole and all the way up to that rear face there. So this is a great capability within SOLIDWORKS MBD. This is only available if you dimension your part using the Dim Expert tools. This could be done either with the auto dimension scheme or manually. So one thing to note, now we can go ahead and we can take a look at applying some manual dimensions here to make sure that we are fully constraining all of our faces and features here. So let's take a look at maybe applying an angle dimension between our angled flanged face there and our front face. And when we do so, we can tell that that's really the only dimension we needed there to go ahead and control that. We could go ahead and also apply a angle dimension here to control that face as well. And by using the show tolerance status, we can see that our part here is slowly becoming fully constrained. Additionally, we could go ahead and we could add in some datum callouts to the primary, secondary, and tertiary datums that we went ahead and defined when creating this auto dimension scheme here. And then taking a look at our model, we can see for the most part, it's almost all fully constrained. And we're not going to focus in on making sure that all the other components here, like this keyhole, are fully constrained. I think you guys know how you can go ahead and apply some dimensions, just like we did to control these two angle dimensions here. So let's go ahead and let's take a look at how SOLIDWORKS has gone ahead and organized these annotations here for us. So taking a look, we can just go ahead and activate and reorient our views here. For the most part, these look pretty good. They might need some minor cleanup work, but like I said, for the most part, they're all looking pretty good. Everything here looks good. How about our left view? Our left view, maybe we want to just drag that out a little bit. That looks good. And then let's actually take a look at our auxiliary view. So our auxiliary view that we created earlier, notice how this auxiliary view, since we already went ahead and created it, SOLIDWORKS found this and went ahead and associated that new PMI to this specific view. So we don't have to worry about finding this PMI in the unassigned items and relocating it, since we've already created a view perpendicular to this angled face here, giving us that auxiliary view that we're looking for. Now we may have some cleanup work, but that's quite all right. This saves us quite a bit of time by making use of the Dim Expert. So just like that, everything is looking pretty good with all the PMI that we've got so far. Now you may be wondering where we're getting these specific tolerances from. And like I mentioned earlier, since these are in accordance to industry standards, these are all being controlled from the document properties, just like a drawing. Under the Dim Expert, we can see we're actually using this ANSI standard, but we do have the ability to choose from ISO standards and much more to go ahead and control our tolerances here. You can actually see that we can apply tolerances based on specific features. And if we wanted some GD&T, we could also apply those as well. Now I think we've got plenty of PMI. I think we're looking pretty good here. However, if If having all this PMI on your screen is a little bit confusing to work with and to see specifically where something is being called out to, you do have the ability to hide and show those all from the annotations folder, or we could make use of the dynamic annotations views. And when we go ahead and we do that, SOLIDWORKS will automatically show a specific annotation view based on if we're within a certain couple degrees, if we're perpendicular to that face. So here, since we're almost perpendicular to this auxiliary view, SOLIDWORKS has gone ahead and unhid that view for us. But as we rotate here, notice how we don't see anything until we're pretty much perpendicular to a specific view. Now we could go ahead and see those front view annotations there. Maybe taking a look as we rotate this. Now we can see our top view annotations. So this is a great way if you want to go ahead and show all your annotations, but only be able to view those based on what specific annotation view you're oriented to. Now that we've pretty much defined all of our PMI necessary to go ahead and create this component here, the next part that you would want to take a look at is capturing some 3D views. But before we go ahead and we capture some 3D views of this component, I do want to make a point that we have the ability to bring in notes. So just like a drawing, maybe you've got part-specific notes, or you've got some standard company tolerance notes. Those can all be brought into this model here and published as PMI. So you could easily go in and add a new note if you wanted here. But if you've got some company standard notes that you go ahead and you apply to every drawing, well, you could actually go ahead and make use of the design library to go ahead and store that information. So you don't have to recreate those notes every single time here. You could just store those and just drag and drop them in to your drawing here, or to your model, not your drawing here. And you just want to make sure that you have the notes area active. And when we do have the notes area active and we go ahead and we drag in a specific note, you'll notice that when we go ahead and we rotate our model here, that note actually always stays flat to our screen, making it really easy for viewing purposes. So maybe this is a company specific tolerance note that you want applied to every model. You can just go ahead and store that in your design library. The great thing about the design library is that it can also be shared with all of your colleagues, so you don't have to worry about maybe duplicate data entry or someone fat fingering a note. So all this can be stored and just created one time and shared with all your colleagues. Additionally, the design library can be stored for more things than just your notes. It can be stored for features, parts, and maybe even any sub-assemblies that you need. So we'll just go ahead and we'll drag off another note here, making sure that we want all the fillets and rounds that aren't specified to be 1 millimeter. So maybe that's a part specific note that you need. You can just go ahead and drag that into place there. And know that when we go ahead and we take a look at our model here, that is always flat to our screen, and those are stored underneath the notes area there. So now that we've got all of our annotation information here, we can go ahead and take a look at creating and capturing those 3D views. So like I mentioned earlier, most of the legwork is going to actually just be involved in creating those annotations. So let's go ahead and let's orient and activate our model to that front view. We could go ahead and zoom in, maybe adjust the callouts if we want them, adjust it a little bit here, and we could go ahead and capture our view. When we do so, it'll automatically select whatever views are shown here. And we just want to capture the front view annotations. If this part was actually set up with multiple different configurations or display states, you can control those right here as well. So if you want a 3D view that's configuration specific, you have that ability. But since this component here was just created with one configuration, we're just going to go ahead and take a look at creating some other 3D views. So we can just keep working down the tree here for our other views, just capturing those. Pretty quick and easy this part is. Now, say we actually went ahead and we captured this, maybe missing a dimension. I'll go ahead and take a look at that now. And say we're looking at all of our 3D views. We get to our auxiliary view and we say, oh man, you know what? I kind of cut off that fillet dimension there up at the top. Well, you can just easily go ahead and recapture a view by just right-clicking on it, selecting the recapture option, and just clicking OK. And so next time when we go ahead and we activate that auxiliary view, now we can see that fillet dimension is properly oriented inside our 3D view there. So we can continue from here to maybe add some additional views. Maybe we want to show all of our dimensions here and our notes area, and we'll just capture this as one as well, and we'll just call this maybe ISO all. And then if we want one with just our notes, we could go ahead and do that as well. So we're only showing our notes here. Let's go ahead and activate that and hide the rest of our annotations here. And now we've got an isometric view with just our notes area there. Now, since we're working with just a pretty simple bracketry design here, we didn't really need any additional views other than our standard views and one auxiliary view. But do note that you do have the ability to go ahead and create section views, model break views, and even if you're working with an assembly, you can do exploded views as well. So now that we've gone ahead and we've created our annotations and our PMI onto our model here, we've created and captured all these 3D views. If we had a colleague or a supplier, someone that was using SOLIDWORKS, we could go ahead and share this file to them. And as long as they have SOLIDWORKS MBD, they could go ahead and they could actually visualize these 3D views that we've set up here. If not, and they did have SOLIDWORKS, they'd be able to actually view this, but they wouldn't be able to go ahead and set up these 3D views that we have here. They could go ahead and they could still see the model and see those annotations and dynamically highlight where they are. But if they didn't have SOLIDWORKS, so maybe you're sending this to the shop floor and they work with eDrawings files, or maybe a supplier that is running a different program, well, that's when the ability to publish to 3D PDFs and publishing to eDrawings comes into play. Now, both of these publishing options are free. 3D PDFs is free through Adobe Reader, and eDrawings is another free program as well. Taking a look, we'll first start off by looking at the 3D PDF template editor. So we could go ahead and we can publish this information directly to the SOLIDWORKS templates that they come with, or you could go ahead and you can create your own customized template as well. So this is very similar to a drawing, where you'll notice that the custom properties actually get brought over as well. So the part number, date, revision, so on and so forth, all the way to who it was drawn by, who it was checked by. You also notice that there's the ability to carry over notes. So the notes that we went ahead and we imported into our notes area, those will also get brought over into our 3D PDF here. And then also we've got our viewport. So in here we'll have a main view, and then we'll see all of our 3D views that we created will be populated in these thumbnails down here below. One great thing about the 3D PDFs is that it's not a stationary 2D drawing view. You can actually go ahead and we can manipulate the model and rotate it within this viewport here. And additionally, since this is actually an assembly template, you see that we have the bill of materials table that gets brought over here as well. So those are some great things when working with a 3D PDF. You also have the ability to add a comments area. So maybe you're sending this to a supplier. They can go ahead and mark it up, add any comments, and send it right back to you. So let's go ahead and let's take a look at publishing to a 3D PDF. Since we're working with a part, we'll just make sure we're working with a part template here. And you'll immediately notice in the preview area, that our front view gets brought in, we could capture all of our 3D views that we created and bring those into the thumbnail area. And then maybe we want the front view to be our primary view to start. Like I mentioned, we'll see that all the custom properties get brought over. Additionally, our notes that we have brought into our model also get carried over to this 3D PDF here. And then with both 3D PDFs and e-drawings, we have the ability to create and attach a Step 242 file, which is an MBD specific step file that also contains all the PMI information on top of your model there. So taking a look at one that I've already gone ahead and created here for us, we can see that sure enough, all the custom properties got brought over, all of our notes that we had applied into the graphics area got brought over as well. You'll notice we have the ability to go ahead and rotate our model here within SOLIDWORKS or within our 3D PDF as if we were in SOLIDWORKS. We also have the ability to switch between our 3D views that we went ahead and saved here. And a great thing about 3D PDFs is you also have the ability to go ahead and measure. So maybe if you really wanted to make sure a specific dimension was correct, you could double check and make sure that that gap between the two holes there is 30 millimeters. So these are great ways to view your model-based definition here, just removing any ambiguity that you would normally probably have when creating a part from a 2D drawing here. We could go ahead and select our dimension, and you would also notice that it dynamically highlights in the model as well. And like I mentioned previously, if you're working with a supplier and they want it as a 3D PDF sent to them, they have the ability to go ahead and mark this up with any comments they may have. Maybe they're wondering, what material is this to be made out of? They could go ahead and save that and send it right back to us since we don't have a material called out here. Also, like I mentioned previously, 3D PDFs have the ability to be printed. So by going and switching over to SOLIDWORKS MBD, it doesn't mean that you have to go paperless. Additionally, I have an assembly 3D PDF here, for example, just to show you the ability to dynamically cross-highlight between the bill of materials here. So notice when I select that nozzle, it automatically highlights and actually changes the transparency of our other components here that are not selected. And the same thing here when working with selecting from the graphics area, you'll see that we've automatically dynamically highlighted the finger grip there in the bill of materials. Now, for those of you who are working with e-drawings, publishing the e-drawings is even easier. All you have to do is go ahead and click the button, and then you have the ability to create that Step 242 file there. And then when you click OK, it will automatically create that file. So in this instance, you don't even have to worry about adding in any of the notes or custom properties. Those all automatically get brought over here for us into our e-drawings file. And so just like our 3D PDF, we have the ability to go ahead and rotate this, just removing any ambiguity, making sure we know where all of our dimensions are being called out to. Also, when we go ahead and we select a dimension, notice how it dynamically cross highlights in our graphics area, completely removing any ambiguity. So now we don't have to have our suppliers come back to us, maybe asking for specific dimensions or asking for any clarity. They should be able to go ahead and figure out exactly where these dimensions are being called out to. Like I said, the custom properties also get brought over into our 3D e-drawings file here. Our 3D views get brought over as well. So if we wanted to take a look at that, in those specific orientations, we can, and this is a great way to do so here. Also with e-drawings, you have the ability to mark it up. So very similar to 3D PDFs are e-drawings. So it all depends on who you're working with and what you need to go ahead and send these to if they don't have SOLIDWORKS MBD. And like I mentioned previously, since all this PMI is actually stored in the model, we don't have to worry about updating a drawing for a revision change as well if we were to make a change to our model. So let's take a look at maybe just changing a simple dimension here in our model. So maybe we wanted to change the width of this. It's currently called out to be 76.2 millimeters. Let's go ahead and just change that to 70. And you'll notice when I do so, and we switch over to our 3D views, I take a look at our top view here. Notice how the PMI has automatically updated for that change. So since that PMI is stored in the model, we don't have to worry about updating another drawing as well, since all that is stored right here in the model. So making revisions or changes even easier for you. Hopefully that should save a lot of time and a lot of headaches that you might have that are currently associated to updating drawings. So as you can see, SOLIDWORKS MBD provides easy to use tools to define, organize, and publish your product manufacturing information all inside your model to help streamline production, cut cycle times, and improve your product quality. I hope everyone enjoyed and found this overview of MBD to be very useful. Thank you.